So good afternoon, everyone. My name is Faye Magicudemy, Senior Transit and Rail Engineer at Gannett Plumbing and WTS Philadelphia Director of Professional Development. First, I'd like to thank all of our corporate sponsors for continuously supporting our chapter and also supporting our initiatives. Thank you for all your participations in today's technique event to learn the best standard practices to incorporate inspectability in bridge design. Before we introduce our subject matter expert, I'd like to introduce WTS Philadelphia Technique Chair, Lee Wolf, who has helped to organize this special event just for you. Lee?
Thank you so much, Faye, and good afternoon, everyone. Welcome and thank you for attending today's presentation, Bridge Lifecycle Cost Savings through Inspectability Design. Before I introduce Jen Lanning, I have a few housekeeping items. Please place any questions you have during the presentation in the chat at the bottom of your screen. There will be time for questions and answers at the end. I will be placing my email address, pdh@wtsphiladelphia.org, in the chat. If you wish to receive a PDH certificate for one PDH for this event after the event is over, please send me an email listing 4 things you learned from the presentation. Also, Jen will give you a code word at the end of the presentation. Please include that code word in your email. I will keep a copy of the email as a record that you attended the event and email you the certificate. Jennifer Lanning, PE, is a Vice President at TranSystems with a primary focus on bridge inspections and project management. She also serves as the Bridge Inspection Practice Leader for the East Region. Her responsibilities include project and quality management of NBIS bridge and underwater inspection projects and coordination of relevant project requirements for local, state, and federal clients. As practice leader, she provides cohesive leadership for bridge inspection projects, ensuring that the project deliverables are consistent, technically sound, and of high quality. Qualified as an NBIS project manager, she integrates the assignments and work priorities of bridge inspection team members into a comprehensive plan and schedule to fulfill inspection commitments. Jen also performs quality assurance, quality control reviews on bridge inspection reports and related bridge rehabilitation and repair projects. She has background information and experience with the U.S. Army Corps of Engineers in bridge program management, rehabilitation and repair of bridges, coordination of projects with multiple agencies, and leading multidisciplinary design teams and bridge inspection teams. So welcome, Jen, and take it away.
Thank you so much for inviting me to share today, and I hope everyone really enjoys the presentation. This is based upon a presentation that I gave last year to the National Council on Structural Engineering Organizations, and also it has been previously presented at IBC, the International Bridge Conference last year, parts of it, not the whole thing. So as Lee and Faye mentioned, you know, I've been doing this for a really long time, 31 years. Manager under the NBI, and also I'm a former bridge owner myself. 14 years I managed the bridges across the C&D Canal for the Army Corps of Engineers in Philadelphia, and they're all long span steel structures, high level bridges, and I started doing that like right out of school. So I have a long time of working on both the public side and the private side, and I will say that much of what I cover in this today is really just a lot of perspective about what I do for a living and what the folks I work with do for a living, and how this work really relates to what I think is an incredibly important topic now, which is the state of our infrastructure and how we're caring for it, how we continue to care for it, and how we could be more, I think, optimized in caring for it when we are working on design projects. So first, we want to kind of set the table and talk about inspection requirements. So the NBIS, which, you know, as a lot of you may know or may not, actually is recently changing the standards for bridge inspection, but it didn't change things that are really important called the intervals, which is how frequently the inspections of publicly used structures must occur. And actually, one of the big things they changed in the new inspection standards, they changed it from the word frequency to interval, which I really like, because I think frequency is one of those words that, you know, is it more frequent or less frequent? You know, it's kind of interpreted. So they use interval now, which I really like. And they also have new requirements, you know, for fracture critical. I didn't change that here, but the new term for fracture critical is non-redundant steel tension members. So, but fracture critical members are those that if there was an incident or an issue with the member, that the bridge could be rendered compromised or inoperable. So, and then the procedures for inspection. So you're going to see people, you know, for those of you who don't know, you're going to see people on bridges inspecting them at no more than 24 months. Sometimes it's less if the bridge is in a particularly challenged condition, but that's generally the status. And then the procedures for bridge inspection are in the AASHTO manual for bridge evaluation, the bridge inspector's reference manual, and different states also have their own manuals. So part of inspection requirements is it's a pathway, right? So there's general condition ratings for 1 through 9. And then there's now, you know, newer standards that make you provide element condition states, which basically relate the condition state to quantity and are more, what do you want to say, granular in terms of talking about the individual components of a bridge and where they all fall. It all relates really back to, you know, is a bridge in good, fair, or poor condition? Then you add in things like appraisal items, which is, you know, our traffic safety items and deck geometry. And the new SNBI actually kind of really takes a hard look at a lot of the traffic safety features and tries to relate that to, you know, what the design standards are. So that's gotten a little more complex. And so overall, where we're really at is, you know, we're looking at the deck of the bridge, the superstructure of the bridge, the substructure, and then the channel or the waterway. So overall, trying to decide where the bridge stands. And, you know, and every year you get these, you know, governmental, you know, releases of data because all the data is reported back, and it talks about, you know, where the state of the bridges are in you know, in the country, and how many are in bad condition in a particular state. And it, you know, really relates to, you know, funding and all those things. And as you know, now we have a lot of the infrastructure funding out of the transportation bill, and taking a hard look at how we can do a better job of keeping our infrastructure in better condition. So in the end of the day, you know, inspection access is really what it's all about, and being able to access the bridge components and do that in a safe manner. I mean, everything I'm going to say here really relates to also safety of the traveling public and our inspection folks. You know, we need to walk the deck in some way. We need to look and touch, you know, the superstructure, which is all the portions of the bridge that's below the deck. Including, you know, those fracture critical or NTSM components. And then, you know, we also have to do damage and special inspections based upon, you know, was the bridge, you know, struck? Is there been an earthquake or a natural event? You know, or is there a portion of the structure that we're keeping an eye on for a particular reason? Or if there's a special requirement like gusset plates for a bunch of structures that you need to perform inspections to get detailed information. So there's different types of structures, and you know, we have, you know, roller structures that usually are smaller, they are simple. They might have low clearance or narrow approaches that need to be addressed. But then really getting into highway structures carrying mainline highways or ramps or grade separation structures. I'm going to try and hide this thing at the top. It seems to be, yeah, here we go. Mainline highways or ramps or grade separation structures. And then we have the really complex movable or signature bridges that are long spans. And in each of those, you know, you have different requirements, but we're really going to focus on highway and the complex and movable signature structures, and how inspectability is important to being able to properly assess what's going on with these bridges. So how do we get there? And, you know, there's various methods of access. And, you know, this picture here is the Chesapeake Bay Bridge in Maryland. And as you can see, sometimes we're really blessed to have access because there's ongoing construction, and we can, you know, work at will, you know, which it's rare, but it's great when it happens. But decks, abutments, you know, usually embankments at the approaches, they're usually by foot. The superstructure, you know, you have snoopers, rigging, man lifts, bucket trucks from the ground below. And then, you know, when you have substructure, you know, especially tall piers or towers like these, you may have to, you know, rappel them or use, you know, man lifts if it's over ground, or from a barge with a man lift on it, and or from boats. At the end of the day, this is where, you know, the main part of what inspection folks do for a living, this is where the challenge is, right? Is how to do this most efficiently, get the most time on the bridge, and do it the most safe manner possible. But I think you got to like take a look back at like inspection costs, right? Because, you know, you're designing a bridge maybe for 100-year life, and there's going to be costs associated with that bridge over the lifetime of the bridge. And, you know, far be it for me to speak to, you know, design considerations and those sorts of things, because that's not really what I do. But I think it's important to consider when bridges are under design to think about how the inspection costs are going to accumulate over the life of the bridge. And that may be in, you know, several waves, you know, based upon when a rehabilitation is scheduled, or those sorts of things as the condition, you know, changes over time. But you have to consider, you know, things like the labor for an inspection. You have to consider access equipment and what that's going to cost you to get to the bridge. Then the labor that does that, you know, that does that work, you know, travel, supplies, safety. And then you have, you know, what we're going to find and tell you as we inspect the bridge, what the maintenance and repair costs identified in order to maintain the safety of the bridge. So, you know, when the bridge is brand new, it's going to be pretty static. It's going to be 24 months, that sort of thing. But then, you know, if the bridge is allowed to, or finds itself in a period of decline, then, you know, your costs may increase for inspections, because maybe the interval will shorten up, or people have to spend more time on the bridge. And then if they do a rehab, it'll drop down again and then go back. So, you know, those kinds of things, you know, have to be considered when you're thinking about the costs of a bridge over its lifetime. So when you're thinking about, like I said, thinking about that cost breakdown, you have, you know, the labor, if it's complicated, access, you know, you have traffic control limitations, cancellations, you know, due to weather, or, you know, especially if you're working from the deck, you know, in a snooper, because, you know, you can't take the bridge if it's raining, you know, it's not safe. And then you know, if you have a bridge in poor condition, it can increase the time on site, because you have to document the defects or take section loss measurements that would require you to, you know, do a load rating for that. And then also the condition of the bridge can increase the report preparation time, because you're writing down all this really highly documented information. So, you know, that's also a consideration when bridges are in either, you know, a challenging access and or a compromised, you know, condition. So just to, you know, throw some numbers out there, you know, a snooper, you know, which is a, you know, an access crane or whatever, his daily cost is on the area of about $3,500 a day. And that doesn't count, you know, mobilization, demobilization for, you know, that period of work. Man lift can cost about $2,000. Safety boat that's required when you're working over water is $1,000. Traffic control can really vary, you know, depending on where you are. But for most highway situations, it can be, $2,000 or more, depending on the requirements for that particular bridge owner, and then to have additional truck mounted attenuators if you're running multiple crews. And then everybody who does, and I know everybody who's on this call, I see some familiar names that know what we're doing here. Let's talk about railroads, right? And everyone's going to nod and say, yeah, that's painful, because it can really make life complicated for you. And there's a whole other aspect of this that, I don't really touch on a lot, but depending upon, the bridge owner, if it's, if they're restricting traffic on the structure, or they have shortened up hours for access based upon it's a commuter route, or it's a tolling authority that wants to avoid impacts to travelers, if there's certain directional situations, if it's a hot lanes or an express lane scenario that they don't want to allow you in there in certain time frames. So you can really find yourself in, you only get 5 hours, or you have to work at night and those kinds of things. So, you have to respect the traveling public and work around that. And it can make things really difficult. So thinking along those lines, that can definitely have an impact on the cost to access the structure. So when you're looking for alternatives, part of the reason why we look for alternatives is we do that for cost reasons, right? So you can see in this picture that's 95 in Wilmington over the Christina River in that picture. And, you could take it from the highway, but it's going to be impacted by timeframes that you can't close the bridge down, except between 9 and 2, and you can't do it in the mornings because it's going inbound to Wilmington. Doing it this way with a boat, we don't have the same kind of considerations. The cost may be either equal, or it could be more because the boat's expensive. So sometimes you're doing it to get more time and be more efficient from a labor standpoint. And sometimes you're doing it because it's cheaper or cost comparable to do it in another manner. So, for complex structures, you want to look at ways to maybe spend less time in a snooper because it reduces the traffic control costs. It's a conversation that we're always having when we're trying to price things out. So some alternatives include, for example, bucket boats or barges with man lifts. The cost is about the same, but your time can improve because they can work from 7 o'clock in the morning until 3 or 4 o'clock. They don't told, it's 2 o'clock, you have to come off. Rigging, is a cost equal, maybe sometimes increase, but your time can improve. One of the places that in my experience we've used rigging was the Chesapeake Bay Bridge, because the time opening window there is very, very narrow and also extremely weather dependent for taking a lane. But if they used rigging, they could work from 6 in the morning till 3 o'clock or whatever, and not have to come off. So also if things back up a lot, sometimes you have to get off the bridge. Rope access or industrial access techniques, rope access techniques can be cost equal or increase, but sometimes your time can increase, and that still might be valuable to you because you can be on the bridge for a lot longer. The use or placement of catwalks can help with some aspects, and walking the lower truss cords instead of doing that with a snooper can be a cost reduction, and your time can improve on the structure. So these aren't hard and fast, but those are kind of the conversations that we have when we're looking at how are we going to inspect this bridge. And you don't always, you don't always take like, well, this is how we've always done it. Sometimes you have to be creative and be, and challenge yourself to look for new alternatives. So overall, why is inspectability important? I'm not a designer. I'm very actually vocal at saying I'm not. But I do think that we bring a lot to the conversation from an inspection standpoint, because your standard practice as designers, and I've been involved in some design work early in my career, but the standard practice is to consider, biddability of the construction documents. If I spelled biddability wrong, I'm sorry. Constructability of the design, right? And then operability of the asset, right? So, but where does inspectability fall in there? And I think that sometimes it gets ignored. And there's a link between practical design, which is really thinking about, like, does this design make sense? And inspectability, because upfront planning, like I said, can really impact the long-term costs and how even operable the bridge is over the life of the structure. So there's numerous papers and technical notes. I was actually really surprised when I originally wrote this presentation and the article that's associated with it, because I thought, oh, I can't be the only one that's like frustrated about this. Let me see what I can find. And I actually found quite a few references that really focus on kind of looking at ways to improve current inspection challenges and offering proposed modifications for future design practices. I have had opportunities in my career where, you know, there was a design and, you know, I was kind of sitting on the side of, you know, hey, you know, help us have this conversation about where we could take this. And I would say things in meetings like, hey, well, what about inspection? And really, like, a lot of people were like, oh, you know, you're right. There should be a way to do what you're suggesting, you know, in the future, in future kind of safety and access inspections for the future. So this paper by Alan Polly and Yanati that really talks about the responsibility of bridge designers to ensure that bridge details are designed in such a way that you can visually see everything, because that's really, at the end of the day, it's a person looking at things, and that you know, decisions taken during that process can influence the bridge service life. Okay, so great. Now you come into this next paper and they talk about that regular inspections and maintenance. So it actually brings maintenance into the conversation, talks about the importance of considering the inspectability of a structure during the design procedure, including locations that are prone to deterioration. And again, I know that all my friends on this call that are inspectors, they're nodding their head vigorously with, boy, that's the hardest thing I've ever had to try and like stick my head inside of to see if it's, you know, still good. And that, you know, you want to look at ways that you think about these critical details, right? So again, a great reference. And then finally, the FHWA has, you know, a framework for improving resilience of bridge design. And resilience is like a really big hot topic word right now. This dates back a little bit, but talking again about failure design and fault trees and thinking about how problems with regular inspection that kind of like increase over time, that become more problematic the longer they're in place. And I think a perfect example, you know, I'm kind of jump ahead a little bit, is like a, you know, a connection on a truss that has like 4 or 5 different members coming into it. That's only going to get more complicated the older the bridge is, you know, when you have pack rust and debris that gets lodged in there and water, and, you know, water is our enemy, of course. So looking at a design that doesn't facilitate inspection of the bridge components. So, you know, thinking about these things. So use of BRIM, which is in an ASCE technical note reference, to utilize a digital representation to explore the inspectability of the bridge. That's something I don't think that, you know, everyone talks about BRIM now and how it's great for design, and, you know, it kind of connects that, you know, the open roads modeler and all those kinds of things to Open Bridge, to, you know, fabrication and design. I think there's a component that we're not looking at, which is looking at digital representation of a bridge. And then, you know, we also can really look at, you know, how we utilize drones or, you know, UAVs to, with high definition cameras to support bridge inspection. And the new SMBI that I've referenced has a lot more latitude in there for the use of drones in a programmatic sort of way. You know, it's never going to necessarily replace people, but I think it can be used to help us do our jobs. So the takeaway from the references is that, you know, thinking about the cost of time spent during design to address inspectability can help with best practices, right? And then also agency manuals require that designers consider inspectability. I saw tons of them when I was writing this. I honestly can't tell you if that's really considered. And I honestly can't tell you if we're at the level of the third part of this slide, which is there an actual design review where a subject matter expert in bridge inspection, someone who does it, you know, on the daily, is taking a look at plans and saying, you know, this could be better. I don't know. I don't know if that happens on all the time. And I think it should. So that's, again, Jen Lanny's opinion. But so when you're incorporating inspectability into design, there's 3 ways that we can go about it. And we have these icons to kind of follow through. So considering like the TS&L kind of level and design details to, when you're thinking about, to think about inspection. Improving safe access, which, that's the primary, goal of all of us. We all want to have our people come home every night and have people who are driving on the roads be safe. And then finally, that kind of connection between the 2 things, which is improving the ability to inspect the bridge visually. They all seem like I'm saying the same thing, and in essence, you are. But I think, like I said, some things we're not going to be able to do anything about. And I do have acknowledgement, some of these things where I'm like, you can't really do much about it. But it is a factor when you're, when you're working in this situation. So looking at bridge type selection, details, right? Our objective is to increase visibility to the inspector by avoiding uninspectable elements, right? So we don't want to have lack of visual access to monitor the condition, and we don't want to have areas that are unable to be cleaned or maintained, because that's just going to make things really difficult. And then we have a couple of examples here. So pre-stressed box beam bridges, areas behind end diaphragms, and areas on trusses. So let's kind of like go through those. You have, non-composite box beams, right? Everyone knows about the one that failed in Pennsylvania, and, they're still all over the place as much as they already existed. But because of the configuration of the box girders, girders, the webs are touching. There's no deck or sometimes a bituminous wearing surface. You can't inspect the adjacent webs. You can't look inside the boxes. And then usually there's interior issues with the relative, there's issues with the relative movement of the boxes, which relates to, water intrusion and cracking. And, it's a fact. It's a design detail that it's just challenging to inspect and have a confidence, like, you can see as much as you can see, but you can't see everything, right? There was a failure in 2005. And, as a result, in kind of response to that, for example, PennDOT has very specific inspection and rating guidelines about this type of structure. And as a matter of fact, allows for the entire rating to be controlled by the condition of a single beam. So how do you, address inspectabilities of these type of structures moving forward? I think thinking about that, how problematic are they? And, things like making sure there's no water in them and those kinds of things. So this is one case where you don't really have a solution. It is what it is, and it just needs to be, considered when future designs are being, put together. Another case that I've dealt with in my experience is that, for example, there's, you can see in the bottom picture that there's, box girders that are right up against each other over a pier, and presented a real challenging inspection access for between the backs of the ends of the 2 girders over top of the pier. And it was a very small space. It was located under the joint. So it's really a maintenance issue. But how do you inspect that? You have to be prepared to get access to that area with, I think we use cameras and kind of had some of the smaller inspection team members kind of access that area and take a look in there to make sure that we had visual confirmation of what was going on in the conditions. But a lot of debris and those kinds of things that that presented a challenge. And again, it's a design detail that definitely is an inspectability issue. And then you have here, this is a video from the Bay Bridge, the Chesapeake Bay Bridge, which I mentioned it, you have these, congested areas of truss members that really need to get up in there, and you have to look at it where water and debris can be gathered in those areas. Sometimes there's bird nests, to be able to visually access it. And I think this video kind of gives you an appreciation for how really big that whole connection is. It's not, you're driving under it, you don't maybe appreciate that, but it's humongous and has a lot of areas to take a good look at. Looking for adequate drainage to make sure, and if there's drain holes or, if there's congestion of things there. Typically the debris might be worse for the same kind of connection that's like below deck off to the side, because the road debris might fall in there. But again, just making sure that there's adequate drainage, and for the below deck portions that it's maintained, and cleaned out. So now we want to talk maybe about that second item, which is improving safe access to inspectors and the public, safe while we're working safely for the public. And this, I think, is where we maybe can have the most impact from the design to the inspection step, right? Because we can consider this at the initial design level or during major rehab, and small changes can make a tremendous impact. It can improve accessibility. It can improve the cost of the inspection. And, ideally, let's look for ways to get inspectors out of the traffic lanes. And, I'd just like to take a moment, because there was a terrible accident, disaster down here, tragedy in Maryland just last week. It was a construction site, but there was an accident and it killed 6 construction folks on 695. This is why we have to look for ways to get people out of traffic lanes as much as possible. Distracted drivers, can really, poor drivers, distracted drivers can really result in a tragic situation that, we're all still thinking about that down here in Maryland. So, but back on track for this, catwalks and railings around pier tops, fall restraint systems, locations where you can use industrial rope access or traveler systems, staging areas, portals, and tub girders. So let me kind of go through this, because I think the pictures really help tell the story. So you have to talk about both cases on both sides, right? Changing the access methods to work from below the bridge, and like I said, I'll be 100% honest, like, they present you with a better opportunity to work for more hours, or get a different perspective on things, but sometimes they also present a second set of challenges in terms of how you do that work. So, you have to be prepared for that opposite side of things, as opposed to, like I said, so like what I'm going to show you here, I'm going to talk about in a minute. Doing things with this traveler system required some, considerations of how do we stage this, traveler, how do we get it to where we need it to be, that, in a different scenario, someone might say that's just too complicated and I don't want to do that. I'm going to go back to doing things the other way, but I'll talk about that in a minute. So, so one of the bridges that I'm familiar with is the Roth Bridge, which carries Delaware State Route 1 over the Chesapeake and Delaware Canal in Delaware. It was opened in 1995, and there was definitely some inspectability challenges when it first opened. There wasn't at the time tie-offs on the pylons for rigging or industrial rope access in order to inspect the above deck portion of the pylon. There wasn't a consistent method for access for the cables. And then there's this interior web right here. I don't know if you guys can see my mouse, but like the underside part, there's interior web faces in between the parallel sections, because the bridge was so wide, and the wings, quote unquote, wings of the trapezoidal shape were so wide that a snooper could not come up on the other side to look at that interior web. And when you got down in the approaches, there's really no way to look at that. So, especially in the overwater portions, of the structure. So that definitely is a consideration. Now, on the other side of it, you have the Baldwin Bridge in Connecticut, which is a similar, not exactly the same, similar structure. It's not a cable stay, but it's segmental. They have a catwalk that's on the inside web of both of the segmental sections, so that people could walk that and look at the interior web. And you can see right here exactly, the snooper just can't come around and come up the other side in sufficient manner, but because they put the catwalk there, you could go and inspect. So, there's a comparison of, one way versus the other way, and a thought that kind of considers inspectability in the long term. We have the Charles Cullen Bridge, is also in the Indian River Bridge in Delaware. And this one opened in 2012, and it's a different type of cable stay bridge, and it's not as high as the Roth Bridge, but they thought this one through. They have a very wide sidewalk. You can see it down in this picture on the bottom left, that can carry vehicles and is rated to carry a snooper. And they have like a little gate that opens up, and you can basically put a snooper out on the bridge to do the inspection, which is fantastic. They have access points to the sidewalk, and they have fall protection systems inside the pylons. So they put a lot of thought and a lot of effort into considering how to inspect the bridge and the best solutions to at the time to make it easy and doable. So now we move on to like an older bridge, right? And this is the Burlington Bristol Bridge. It's as you can see, it's getting on to be 100 years old, and it has functionally obsolete. But you know, there's portions of the bridge, the lane widths are only 10 feet, and for a period of time, the inspections were only done at night, and there was like, because you had to flag it, it's only 2 lanes. And the safety condition of the snoopers, because there was trucks and it just was not working. There was some, you know, mirror hits and those kinds of things. And so you don't want the snooper to go over, you know, like all of this stuff. So, but it was just becoming evident that, you know, you needed to be doing this in the daytime, and it was safer and better for the condition of the bridge. So we looked at a lot of things, especially after the I-35, where we had to inspect it, you know, because it was a truss bridge with gusset plates. And we kind of recommended a different approach to this and said, you know, let's look at this and in terms of a maintenance traveler system, right? So this is the bottom chord for you can see right here, there's the truss and the main lift span and the tower spans, the back spans. We went in and we installed this rail. It's just basically an I-beam on both sides of to the bottom chord. And we use these mechanized rollers. They're called trucks, but it's basically like a powered roller system that moves a suspended platform along the bridge. And so going back to that photo where I started talking about in the beginning, that's where the boat comes into play, because you have to kind of stage this platform and have it come up from the water, bring it around the pier when you want to go to the next place. But the great thing about it is that this is a window washer's, pick or a platform. It's rented, they maintain it, they make sure it's good. You know, there's no maintenance on the part of the crews that run the bridge, and it's certified and comes out, and it doesn't require long-term maintenance. And this really gave the inspection team the ability to kind of walk along the entire bridge, look at anything they wanted to, and has really improved the ability to inspect the structure in the daytime, but also give you a good amount of time on the bridge from a safe perspective. So I think this one, you know, this was a good solution, and it was a rehab solution for this structure. And so then finally, and there's a bunch of slides for this, but improving the ability to look at the bridge visually. And some of these are, you know, very similar. It seems like I'm saying the same thing over and over, but sometimes you can't fix it, and it is what it is. And that's, you know, it's just a fact of what we do in terms of our business, you know, but we really want to make sure that inspectors get sufficient visual and hands-on access. And even if it can't be solved, the request I guess I make on behalf of inspectors everywhere is, think about it when you're doing the design. Just think about, is this the best way to do things? And I'll feel vindicated, or at least that someone listened. But you know, looking at constraint, you don't want to have these constrained or congested areas, areas that accumulate moisture, debris, roadway de-icing materials, those kinds of things. You have areas where there's like a lack of visual access to monitor condition over time, so that it's really hard to get to it and keep an eye on it. And so then there's more of a likelihood of a problem or a deterioration of the bridge components, or, you know, materials or areas that are unable to be cleaned or maintained. I think everybody, any bridge designer anywhere, you know, we all know joints are a problem, and that's just, you know, whoever can invent the the jointless joint or something is going to be, you know, a millionaire and a savior to us all. But in general, you know, it's those kinds of things. So when you're taking a look at, you know, when you're trying to plan and prepare for an inspection, here's the facts, right? Inspections happen every 24 months. You know, it's going to happen. We want to be productive and efficient because, you know, let's face it, we're, you know, it's a business, engineering is business. We want to be productive. We want to get the work done and we want to be efficient about it. Delays that we can not control, weather, traffic, you know, railroads, whatever, and inefficiency, which means we take a lot of time, can't get where we need to go. They affect that cost. And 90% of, you know, doing inspections, you know, like the secret I always say to people, it's really not that hard. The hard part is the planning and the prep and getting out there and making it look easy. That's what we have to consider. So when you're thinking about it, you have to think about how we're going to do it and when we're going to do it. And that's how you come up with what you want to do. So you have to think about too, when you're putting together maybe your cost proposal or your plan, what has changed since the previous cycle? Are there specific defects that have, you know, we have to monitor? How will, you know, how are we going to get to the stuff from above or from below? How are we going to get to bearings and areas on the slopes? You know, one thing I'm seeing a lot of right now is areas that are, there's wires right along the abutments of a bridge. You know, it's just a regular old highway bridge, but there's wires there. And, you know, we can't go within a certain number of feet of them until we are sure that they're not powered, you know, because of safety reasons. How are we going to get to pins or cable ends? The number of pins that have caps that you're asking an inspector to like wrestle this giant, like, you know, 50-pound steel cap off of this in a snooper that's over water and everything's bouncing. I mean, like just those kinds of situations. And then, you know, finally, is there construction in the area? Because that could impact, you know, where you're working at that time. So here's some challenges, right? Obstructions on the overboard side. Now, you know, in this case, it's a truss. Can't do anything about it. There's going to be a truss, right? Considering use of catwalks or travelers to get to some parts of the floor system, but you still need to inspect the outer faces of the truss. And, you know, I would be remiss if I didn't like bring up, you know, the Hernando de Soto, where, you know, the use of a drone was kind of being used to replace a little bit of the other inspection, you know, techniques, and that, you know, there's a lot of discussions about, you know, use of travel of snoopers and not use of snoopers and those sorts of things. You have to, you know, you cannot adequately inspect the bottom chord of a truss from a catwalk. So you're going to have to use a snooper, but if you can only use it for certain parts and, you know, do floor system from other things, then maybe you can gain some efficiencies. But every bridge has a different set of characteristics. I did have let's see if it works. If it doesn't work, we can just move on. Okay, so here's the, you know, using the snooper or using the drone to kind of, I don't know why it's not playing. Is it playing? Oh, it's playing. Using the drone to kind of inspect the hangars on this bridge. I don't know. There we go. They were doing that, and then, you know, as we can see, there's value here to doing that. Just, you know, you can see here, you still kind of have to use a snooper because the catwalk that was subject of some discussion was further underneath the bridge, and you weren't going to be able to see the bottom truss from that catwalk to inspect it as a, you know, fracture critical member, full on hands on, you know, hands on full length. So I'm going to stop it and move on to the next slide. Let's see if I can move on to the next slide. Page. Let's see. There we go. All right. But in other cases, moving on to, you know, talking about obstructions on the overboard side, we've all run into this situation where they put light poles on the outside of the bridge, and you're going along and you're going great progress, you know, whatever. And now you have to redeploy the snooper multiple times to go around this stinking light pole. So we've had similar situations for high chain link fences or super wide sidewalks that you can't go across. So solutions for that can be remediated and designed by maybe putting them in a median, or I've seen certain places where they've just taken out the light poles, you know, for maybe other reasons, but it's resulted in us being able to be super efficient. And the top picture has a different type of underbridge access vehicle called a Moog that's fantastic for these kind of scenarios, because if there's no light poles, you can just roll right along and inspect super efficiently. And in this case, we used it because we were going to be going over ramps. It was an interchange, and you just want to be out of there as quickly as you possibly can and not have to take, you know, 2 lane closures. So, you know, we have situations with curved girder bridges where you have to go all the way across the road. It's not much you can do about it, but again, it's a challenge and it's a significant consideration for inspection coordination. Thinking about bridges that have deployment constraints for adjacent structures or even trees, as you can see from this picture, you know, the roadway bridge has a pedestrian bridge right next to it. And by the way, that's over Amtrak. So, you know, you really have a lot of challenges here, especially because you can see on the one side, there's a lot of vegetation, trees. So you have to kind of like, you know, talk to the bridge owner, maybe get things cleared, think about how we're going to do this. And, you know, it's just a whole bunch of challenges for how to best do this, you know, do the inspection. But as you can see from this elevation view, you're really not going to be able to deploy in between the pedestrian bridge and the bridge because it's too narrow. So you pretty much have to go over the other side or work from the rail itself with a cat car. So there's not a lot of choices for you in this case, and the vegetation can be also an issue. You know, we have cases where you have deep haunches that can't be overcome by the standard equipment, you know, where, you know, this snooper is not going to be able to reach all the way down here. So we have to consider, you know, for inspectability, placing catwalks or tie-offs for access to walk the bottom quarter, use rigging so that it can be inspected sufficiently, as opposed to, you know, trying to do it where you can't get down there. So that's again something that can be remediated to make sure that inspection is provided and that it's safely done. We have, you know, cases where there's bridges that are load posted and the only solution is potentially rigging because you can't put a vehicle on it. And you know, in that case, you know, again, you have to think about how you're going to do this. And it's just a challenge. But usually, sometimes you're in a case where, you know, your choices are very limited because of the condition, you know, of the bridge. And, you know, unfortunately, that's the way it is. Hopefully, we aren't letting some structures get to this case where there's not a choice. Here's a great solution that actually, so when I worked for the Army Corps, we managed this bridge. You know, and there's a ton, it's very long, it's 8,000 feet long. So it's a 2-lane bridge. And so you want to do as much of the bridge as you could from not the roadway because the backup was incredibly long and it really caused a lot of stress with the local people. So what we did do is we kind of stoned the area under the bridge for the length that we could do from the canal all the way back so that we could do the work with various man lifts. And it made for a much improved inspection because we didn't have to close down the road for as much. And it was really easy to do that work. So that was a solution that we came up with that made it a better and safer option for the inspectors. You know, here we're going back again. Like I said, a lot of this is interrelated. So talking about congested areas on trusses and really looking for ways, you know, sometimes it's much better. You can kind of see the snooper. There's a snooper in this picture all the way to the back, but we had, you know, access with climbers because of how congested it was to try and get the snooper into certain areas based upon how much steel there was. And so you could look for, you know, permanent you know, rigging tie-offs or doing it with industrial rope access or rigging. And like I said, too, catwalks can offer a lot of assistance to this. And so I guess my point in some of these cases is that it's not you're not going to have a one size fits all solution. You're going to have multiple solutions that but again, you have to think about that when you're coming up with your plan to make sure that everything gets looked at on the bridge. We had a case here where this was an open spandrel arch, and just because of where it just was way more efficient to use a bucket boat, but the interior of the arch had to be inspected, and that's a confined space. So, again, a combination of efforts, but looking for ones that least impacted the local road and gave us plenty of time to do the work from down below was a better solution in that case. So this one is, this one's one of my favorite ones, actually. We have a lot of structures where there's a very steep slope embankment coming off the bridge, or there's these MSE walls, and there's a bridge owner up in Delaware River Bay Authority, where a few of their bridges that are kind of like in ramps, on ramps and off ramps, they basically came in and provided a walkway right up against the bearings on the abutment / MSE wall that allows for access to do the inspection, that takes the truck out of the situation and the traffic control. And that is amazing. And I think if we considered that a little bit too, when we slope the embankments on, maybe a highway, a grade separation structure or a ramp or whatever, where we can cut it back, but it's either, sometimes it's paved with sidewalk type paving or with a lot of riprap, but putting a flat area near the top to make sure that inspection access is safe, and that people aren't going to, maybe have a tripping hazard or that, danger in that way, would make it a lot easier. It's a simple solution to a challenge to make sure that people can, just be safe while they're working. We've talked a lot about access, but, sometimes you have these cross girders, and I can't tell you how many, that they're tight and confined. Maybe the doors don't open, and then the access is outboard of the bridge. So how do you get into it? So there's a lot of challenges with those kinds of things. And, I'm not a designer, so I don't know what to offer, but, the access to those are not always easy for people. They can be small. And, you're asking people to transfer from a bucket truck or whatever into this tiny space. So, we have to test the area and that kind of thing. So, those are also consideration. And then looking for ways to think about where a detail is placed and what is over is also, again, I offer that to just thinking about those things. Here's another case, again, where the member is located outboard. So to do the sign structure that's over here, they have to either climb over from the top to test the, to test the anchor bolts, or, get a bucket truck and come up from the underside for the regular NDE. And it's just really awkward and in a weird spot. So, again, it's just kind of an interesting thought process for, how that configuration came up. Did anyone think about how that was going to be inspected? We talked about access for NDE and pins, and we have this case where there's a pin cap that had to be taken off. But one of the things that happens here, and this is, I think this Indian River, they have these giant caps, the very, very huge giant caps on the ends of the anchorages that have to be removed, on a regular, semi-regular basis. So the caps are very heavy, you got to deal with all these bolts. So it's, again, like, are we making sure that, that's something that people can handle over water or while they're, hanging from the bridge? I think that, thinking about those things in the long term might be a wise choice for how often they need to be inspected. Think about, is it an accessible place on the bridge? So, as you can see, there's not, like I say, a solution or an alternative to a particular challenge. And for existing structures, if you didn't consider, if we didn't consider inspectability way back, maybe there's other ways to either incorporate it during rehabilitation when they're already doing work, or figuring out how to do the work safely. But I just think it's a consideration that maybe, as we're having this opportunity to repair bridges, with the bill and the money that's coming out from an infrastructure perspective, think about inspectability and how, that addition to the process can make more cost-effective choices for the remaining life of the existing structures that we're trying to manage and maintain. So, at the end of the day, costs, affect efficiency. We impact traffic, which is, an economic cost, delays to truckers, delays to commuters, fossil fuels and emissions from, that cost us environmentally. We don't want to have the traveling public and our people working, construction people, inspection people, be in a compromised position. And then, like I said, these are our assets. These are things that we should value. We've invested money over time, and the longer we can make them last, the better we can have an investment in, the overall health of the country in terms of how we get people from place to place and in a safe manner. So that's really the end of my my spiel of stuff. But safety and life cycle cost savings. So I can answer questions if anybody has questions. I'm happy to do that. I don't know if any showed up in the chat, Lee.
Yes, there's a question from, let's see, there's a question from Ed Montgomery.
Oh, hi, Ed.
Should each biennial report have a section describing inspection access in detail?
I think each inspection report should have that. And I think it helps. It helps people plan better. The areas that I think it helps is when they say, the best place to access this bridge is from here, or you need to get, owner access for properties if you're over a particular property. But I do think that sometimes it's good to take a look at, what is listed there in terms of the access, and if it's something that people could, can we do it better? Can we do it more efficiently? Just revisit it. But yeah, I find that there's a lot of value to telling people, this is how we access this bridge. So, but I think maybe it should be discussed too, if there's a challenge, and have people say, we had some trouble getting to this area, and it's, should be monitored in the future, or, maybe discuss it with the bridge owner and say, I think we got to consider, a platform here, or a railing around the top of the pier would make it easier for us, that sort of thing.
Thank you, Jen.
Thank you.
Another question I see is, when is using the drone for inspection, or when using a drone for inspections, are there specific permits required, or is it dependent on the location?
I won't be I'm not an expert, so I'll put that on, I'm not a doctor. But there are requirements for drones, drone pilots, and licensure. Now, that said, there are constraints for drone usage, based upon where you are. You'd have to ask a drone, a licensed pilot or a drone expert. I know TranSystems has a drones practice, and there's people, when we tell them where we want to fly, they tell us what they need to do that. Like I said, the SMBI now gives a lot more latitude, because they had done, the FHWA and some other people had done a pooled fund study on the efficacy of drones and what it brought to the table. And it was a great study, talking about, when it was good and when it can provide support. So they gave it a little more latitude, but I highly recommend that, and I say this as both as a former bridge owner and as a consultant, that you've got to have a plan, and you've got to have an established procedure, so that you're comparing apples to apples over the years. If you're going to have a program where a different consultant is inspecting the bridge each year, just because you're rotating the work around, it may not be for you, because unless you have a procedure, because, you can't compare what the two different consultants have done, efficiently, unless there's, like I said, a standard. So that being said, I feel like, drones have a place. They don't replace people at this time, but they don't replace people, but I think they bring some value to the equation.
Last question I see here is, how has technology changed the bridge inspection process?
I think it's changed. I mean, I won't lie. I'm a little bit of an old school person. I kind of, been doing it for a long time. And the story I always tell is, you can go into any factory, in the world, and there's 100,000 machines, and it's, nothing's touched by anybody. But the last thing, that widget or whatever is being created before it goes out the door, there's always somebody looking at it and touching it and putting it in a box. So I feel like there's a place, I feel like you always are going to have a human being like looking at it. Now, that said, I think there's, value to, if it's correctly applied, and if it's providing value to, structural health monitoring, to non-destructive evaluation, to use of, drones and those kinds of things. I've been a part of a lot of programs where non-destructive evaluation has been really effective in kind of dealing with decks beyond what a person can see, or where monitoring has provided input on that side. So I think there's a lot out there in terms of technology, but I think that you have to really evaluate, like, what, as a bridge owner, like, what do you want out of it, and what you're going to get, and what it tells you. Doing it for the sake of doing it is not valuable. And I feel like I've always said, because I was a bridge owner, I'm not going to recommend something to you that I wouldn't, that's just for the sake of saying that. I want it to be valuable. So sometimes you really have to talk it through, ask what they want, and look for, what's a really good value solution for that uses technology, because everyone wants to be, state of the art, but what does it bring you? You have to think about that. So.
Okay, well, and do you have a code word for us, Jen?
Yeah, I do. I do. I was going to use Patty Gibson's, she calls me the bridge nerd, but for the sake of being grown-ups, why don't I say this? The code word is Indian River.
Okay.
Okay.
All right. Everyone
All right.
heard that.
Thank you so much for having me. I had a good time.
Well, thank you. Thank you
Yeah.
for coming. That was a very informative presentation and much appreciated.
And I have a last slide with my contact information. But if anyone needs to get a hold of me, they can also ask anybody at WTS Philadelphia. So.
Oh, thank you. And thank you, everyone, for attending this session. It's much appreciated. And we look forward to seeing you at the next one.
Thank you.
Thank you.
Have a great
good
day,
day, everyone.
All right.
Thanks. Bye.